A square with side length 2 and the circle share the same center. The total area of the regions that are inside the square and inside the circle and outside the square is equal to the total area of the regions that are outside the circle and inside the square. What is the radius of the circle? So from the problem given, we have a square has a side length of 2. So we can draw that here. It has a side length of 2. And if it has a side length of 2, then half its length is going to be 1. And to solve the radius of the circle from the given conditions, we can set up an equation to find the area of the circle and the square, and then subtract them. So the area of the square is going to be area of square is going to be side squared, and we know that the side was 2, so it's going to be 2 squared equals 4. The area of the square is going to be 4, and the area of the circle, which we know from the formula pi r squared, we have a radius of, we don't know the radius, so the regions that are inside the circle right here and outside the square are the corners of the circles that are going to extend beyond the square. And there's 4 regions here, and each is a segment of a circle, as we can see here. And to find the area of one of these segments, then we need to subtract the area of the square right here from the area of the circle and then divide by 4, since there's 4 segments. And to get that, we have the area of segments. I'm going to take the area of the circle minus area of square and divide by 4, since there's 4 regions. So we're taking the area of the full circle minus the area of the square, so we're left with this. And then after that, the regions that are outside the circle and inside the square are going to be the corners of the square, and these are not covered by the circle, as we can see. And there's also 4 of these, and each is a right triangle. And since each of them is a right triangle, we can have the length of the legs of each of them as r minus 1. Since the square has a side length of 2 and the radius extends from here to here, and so the area of the triangle is going to be half times r minus 1 times r minus 1, or half times r minus 1 squared. And from that, according to our problem, it says the total area of the regions that are inside the square and outside the square is equal to the total areas of this. So this area is going to be equal to all 4 of these. So from here, we know that the area of the circle minus area of the square divided by 4 was pi r squared minus 4 over 4 is equal to half r minus 1 squared. And from here, you can solve the equation. So let's solve it. Pi r squared minus 4 over 4 equals half r minus 1 squared. From here, we can simplify it to pi r squared minus 4 equals 2r minus 1 squared. From here, we can expand this right here. So we get pi r squared minus 4 equals 2r squared minus 2r plus 1. And from that, we get pi r squared minus 4 equals 2r squared minus 4r plus 2. And then if we just combine like terms, then we get r minus 2 r squared plus 4r minus 6 equals 0. And then from here we get r is approximately 1.13. So if we get 1.13, then just plug these values in the calculator and find which one is equal to 1.13, and it's going to be A.